Hey, what's up, peeps? It's Z back with another video, working on some game development, and just wanted to give you a little update, see where I'm at right now. This planet texture, this isn't mine. This is just some internet crap I pulled off on Google Images. So it's got a seam here. It's not a perfect texture, but I have been working on my own 8K planet textures and moon textures and whatnot, sun textures, all that jazz, and just trying to get things rolling, trying to get a vertical slice going, but ran across a bit of an issue. This just happened out of nowhere. So when I'm going towards a planet, it clips. I don't know why. I changed every physics setting I could think of, but I can't really find the solution to that just yet. And it's because my brain is fried working on planet generation. As you can see, I got a sun as the origin point, and then it's generating a few planets out from the radius, selecting a orbit point for each of them, and then each of these planets has an orbit point for the moons that it could have as well. So each planet can have moons, up to 5 moons. Each sun can have up to however many planets you want, and it just keeps going out further. You can switch the sizes for the planets, of course, make them even bigger than the sun if you want. Do crazy stuff. So just working on things in pieces. Once, you know what? I don't even want to work on the physics thing. I know that something's broken, some setting that I changed somewhere where I'm not going to be able to find it instantly. So instead of doing that, I think now is a good opportunity to swap over to a new file and sort of separate the work out a bit. Just as a quick recap, show you what I got here. Input X, Y, Z for the mouse inputs, and then Z, of course, is your Q and E inputs. And then we have the right, forward, and up vector for the camera, which, interesting enough, if I go over here, up vector, so the right vector is the right still, but the up vector is actually going to be this. The up vector is going to be the forward vector, and then the forward vector is going to be the up vector. Weirdly enough for the camera, I don't know why that is, but that's just the way it is. After that, we get everything and we put it into, we'll multiply it by our X and Y and Z inputs, just so that we can get the correct direction, our desired input, and then add all those together to make a new vector, normalize that vector, and boom, we have our desired rotation. Now we need to make it so that the desired rotation, let's save our stick input also. Don't forget about that. The absolute value of X, Y, and Z, and made a new vector length with that. And that vector length is going to be put into this right stick input, saved value. And this is going to be our actual power, I believe. Yeah, a right stick input, just so that we have smooth interpolation using the mouse only, not even needing to use like a float interpolation or anything like that. It just takes the speed of the mouse and it directly applies it to the thrust. And we need to decide on which of these are being turned on and off, because this is just a 1-digit value from 0 to however much mouse movement you have. In order to turn these on and off, we take the center of mass, which we got earlier, way over here, get the center of mass from the capsule component, and then save that, set that as a variable here. Get that center of mass and subtract that from the world location, and then get the cross product of this value, the subtracted center of mass from the world location, of the thruster itself. So I'm taking the actual physical thruster on position, which is angled in such a way where if it fires, it'll give me some Z rotation, which is interesting. So Z rotation in my logic would mean that it's firing in this direction, and it's gonna twist or roll the character around like this in this mouse movement, as you can see, like counterclockwise. And then this one up here is pointing the X different way. Red arrow shows the thrust direction, so it's going to shoot some thrust this way and continue to rotate me counterclockwise. Both of them do so. And then, as you can see, same deal for this. This is pointing forward and this one back. So this would rotate me, like if I'm looking above the character here, it'll rotate me to the right, and then vice versa. It could be rotated to the left if I just do the inverse input for that. So that's what we're doing here in our torque math logic. And so it's the Z position, get the world location of the Z thruster, and then subtract that from the center of mass, or subtract the center of mass from that, and then get the forward vector for the Z as well, and get the cross product between those. So cross product is like a cross between the two vectors, and it's like think of it like a perpendicular vector between the two vectors. Yeah, think of it like a perpendicular vector between the two vectors. And after we have the cross product, we want to normalize the cross product and get our desired rotation finally from way back here. When we normalize that and set our desired rotation, go ahead and get that desired rotation from down here and normalize that value. Now we want to get the dot product of the normalized cross product and the normalized desired rotation dot product. So that's the alignment between these two vectors. And now the absolute value of this dot product will determine whether or not this thruster Z, the same thruster from before, is set to on or off. So set new active, set active, new active. Don't check reset. I think it's fine if you don't. So set active only if this is greater than 0. After it's set active, we can give it some thrust strength, and this thrust strength is going to be determined by however much torque you want. So you can make a variable down here. Just add a new variable, call it torque, and give it a value. Gave it 1000 for the torque. Don't really need too much. It can get pretty out of hand. But torque multiplied by the dot product from back here. Get the dot product, not the absolute value. And multiply that by the right stick value, the saved set value from back here, which is just the vector length of the absolute value of X, Y, and Z. Telling us exactly how much thrust, telling us exactly how much thrust we want to apply to the thrust strength. So you want to pull out from your thruster component and then set thrust strength. And you get this right here, and you're able to set it. So we just want to chain all these together by getting the execute pin from each of them, and just I like to work my way down in a vertical manner, just because that's how the logic is really set up to. It gets too long, honestly, when you don't do it this way. But after all that's done, now we can rotate the character based not on the positions of the not just on the positions of the thrusters themselves, because this would be a little bit awkward if I just, these thrusters are linked to this capsule component. So if I was to turn it in any direction, it would be kind of hard to determine how to get it back to alignment. So this fixes that issue with this torque math component. And after you have all this done, what you want to do in order to input into the torque math, ignore this soft aim stuff I have here for now, but what you want to do for the torque math in order to actually use it, this torque math function, is to input. Here's my WASD input. I made it into a vector for WASD for X and Y, and then Z input is the control and spacebar for up and down. Have that as a vector input going into this lateral thrust macro, and this is our thruster math, or no, not actually, not this one. Here it is, torque thrust. So what you want is just the same thing, same difference. It's the mouse XYZ into the torque thrust. And what I'm doing here, let me get rid of this. So what I'm doing here is getting the right, up, and forward vector for the camera, putting that into the right, forward, and up. And then the input for the mouse into the input. And that's making the input for the X, Y, and Z, splitting that. Just a vector, basically just a vector input here, as you can see. And it's being split. And with all that, I'm going to show you what that does. So in the end, funny enough, the result is very basic, but the math behind it is really fun stuff. So if I look left and right, of course, let me turn the camera movement off for a second, and then you'll be able to see. All right, so up and down, it allows me to move up and down with the character here. I can roll pretty smoothly. I can look left and right. But this is a little, maybe it's a little hard to have fun with this kind of sort of thing because of, you know, how stiff it is. You know, it'll work for different scenarios and ships. Maybe you want this sort of view, but there's something more fancy that we'll need to do, which is soft camera aim, which takes some quaternions, and it allows it to where wherever I'm aiming the camera at, the character will softly turn to that direction. That's what we really want. So I also have this torque stabilizer here just for now to cheat a little bit, and it stabilizes by adding torque in radians. I'll have this done with physics thrusters pretty soon too, using the same math, honestly, just not yet while I'm testing some things. But here's the math for that if you just were curious. It's got acceleration change turned on. Capsule component. So with a capsule component, you want to get physics angular velocity from your capsule component and then multiply that by -1, so we get the inverse of it. And you can do a little v-interp too to make it a bit smoother. Delta time 1, interp speed 1, and then I don't know why I'm multiplying this. I really don't need to. It's just for power, I guess. You could have more yeah, you could have more torque if you wanted to, if I was to use this value, but that would be way too much for this. So let's just leave it at 1. Show you the free spin really quick. Gives me some pretty fine-tuned mouse controls. It doesn't feel hard to control at all. Up, down, left, right. It does matter about your capsule component, your capsule size. If I were to make this a normal capsule and give it a height of like 90, how it usually has, it would still work, but it would be a bit harder to control just because of the lopsidedness of it. It would want to barrel roll more than anything because of it. But that's pretty cool, you know? Maybe that's what you want. You want more resistance turning than anything, and then you could maybe turn off the value for X or turn off the value for the roll and have it work that way. You know, there's a lot of different options with it. Only turn on the roll when like certain values are met or something. But anyway, for this, I like using a sphere, 35 by 35. I could have a solution where it positions these thrusters based on the capsule size, which would probably be the most clean solution in the end, and I'll have a function for that later. But this works pretty well. I might even post this so people can pick it up. Put this on like a Patreon or something. That'd be cool. If you want to use your own, if you want to have your own like thruster logic that works in different scenarios and things, and you could place your own thrusters in different parts of the ship and still have it work. Just plug and play. That'd be nice. That'd be cool. This is something that it took a little while to make. This is actually pretty important. The camera rotation, before we get into soft camera aim, I need to show you how to do a camera rotation correctly. So triggered and completed are being put together just so that it after it stops, it can return this to 0. I'm taking the action value of the mouse. Cubic R is just mouse X, Y, Z movement. Camera sensitivity, I have just 1 for that right now, but multiply the action value by the camera sensitivity if you want to have that be more or less. And then rotation value R needs to be added to the action value. So just make a new vector, call it rotation value R, and then add it in here. vinterp2. The I don't know why I have this, honestly. I don't really need this. I can have it. I can put this in the target, I think, and have a bit of a better result than what I was doing before. I don't know what that was. But vinterp2, I don't know if you need it or not. It wasn't actually functioning having it into the current. So you don't really need it, but it might smooth the camera a bit. Clamp the vector size so that you're not rotating the camera like too fast. And then save that into a set rotation value R. Yeah, since you already got it back here, you did a get rotation value R, but then you want to set it after you do the get so that it can continue to add onto itself. Now just make a rotator. The rotator is going to be a bit different for camera rotation. It always is for some reason. The Y can stay the same, but I just gave it a negative value for the Y because of how my mouse input's set up inside of here. Up and down is kind of flipped. So flip it back using -1, multiply by -1. X is going to go into the Z, and Z is going to go into the X for the roll. That's how camera roll works. And then after you make that rotator, you can save that return value as a rotation input. And this final rotation input will be put into the camera rotation. So what you can do with this too is this final rotation input, you can turn it into a quaternion. So just 2 quaternion, I think. Yep, 2 quaternion rotator, and then turn it back into a normal rotator. So 2 rotator, and then put that into your camera rotation. That's how you do it. This current rotation value is nothing, I'm sure. Yeah, that current value isn't anything. You don't really need to do anything with that. Doesn't make sense to interpret this either, since we're doing it before anyway. So it could just be directly input after you convert it from quaternions and then back to rotation, and that'll give you a nice usable rotation. The rotation value R, I'm constantly setting it back to 0 right here before the add local rotation. Very important, because if you don't do that, it'll just keep spinning, which, I mean, simulates 0 gravity a bit, but it doesn't make sense if you're using the camera, you know what I mean? Like, you don't really want to simulate zero gravity with the camera itself. Just doesn't make sense. Instead, camera's solid and the character is the one simulating. Now, different situation has occurred here, and that is, well, not really like a mistake at all or situation. It's just, look at how misaligned the rotation is from the camera. I want the character to stay aligned with the camera while I'm moving around and looking around and staying facing forward no matter what, no matter where I'm looking. So in order to do that, we need to solve the rotation direction for the camera. So it's basically solving the camera minus versus the rotation for the capsule. And the way that you do that is getting the capsule component first, get the world rotation, turn that into a quaternion immediately, because we're going to need quaternions for this entire thing. And then get the inverse quaternion. Just get that vector, or get that node, I mean. Multiply. You can only multiply quaternions. You can't multiply rotators. But multiply, take that out, and multiply it by the follow camera, and get the follow camera's, whatever your forward camera is, whatever your normal camera is. Get the forward vector of that, and get the right vector of it, so we can make a rotator from X and Z, and we can turn that into its own quaternion as well, and multiply it by this first quaternion. After that, normalized quaternion is the node you want to get, and split that node, split the output into X, Y, and Z and W. So X, Y, and Z, we're gonna handle that one way, and then W will handle it a completely different way. For X, Y, and Z, go ahead and make a rotator out of that to combine it back into its own thing. Basically, we just wanted to split the W in this normalized quaternion from the vector. Now that that's split out of it, the make vector, we can normalize that value. We'll get back to W later, but normalize the make vector value and rotate from axis and angle. Rotator from axis and angle. So I think the value or the node is called 2rotator. Or maybe, yeah, just rotate from axis and angle. That's correct, yeah. Rotator from axis and angle. And you can put this into the axis, but then the angle, we'll talk about the W now. So from W, first things first, go ahead and grab it out and do a less than. So if it is less than 0, condition branch true. So make sure you have an input, by the way, that's coming into this so that you can use it. Input from your actual tick is going to be best. But anyway, get a branch from whatever your input is and put this into the branch so that if the condition is true, set a value called flip axis. You want to go ahead and make a new variable. Make a variable called flip axis, and then set that to 1 if it's true, and set it to -1 if it's false. You can make this a local variable if you have this being made inside of a function. And yeah, because I don't think you're going to need this for anything else. But 1 if it's true and -1 if it's false. And this is valuable for flipping the direction of the angle, or no, not the angle, but the axis. And we'll talk about that in a second. But after you do that, flip axis 1 and -1 for true and false. this execute pin is just going to go into a your torque math function they made earlier. So boom, we got our torque math function, and this is going to be the exact same for the torque math. So you really don't even need to change this or expose this even. The follow camera, right vector, up vector, and forward vector. And now let's talk about the rest of the math here. Go back to after we normalized and got the rotator from axis and started talking about the W and got up here to making the flip axis. We can get the W again and get a absolute value of it. So just pull out, search for absolute, and then search for the cosine and just type in ACOS for that. Cosine and radians. And multiply that by the flip axis. So it's going to be multiplying it by either 1 or -1, which is valuable for preventing some kind of weird flip issues when you're going over the world axis. And it happens only if W is less than 0. That means if W hits a negative value, we want to go ahead and just flip it for it. And we can clamp this value for -1 to 1. I don't know if you really need to, but I say go ahead and clamp it just to be safe. And this gets you your rotator from axis angle value. Put that into the angle. And before we do anything else down here, this output from rotator from axis and angle, go ahead and split this output, and then we'll need to make a new vector with it. And with this vector, you want to flip these values here. So from the rotator from axis and angle, X is going to be the Z value. And I just put a -1 on this as well because we're going to be doing something later here. And Z is going to be -1 also. You could either do that or just do -Y. So Z is going to be negative for the X, Z -X, and X -Z. Y can stay the same. Remember, just flip Y if you want to just do that one by itself. That make vector is going to be going into a multiply, and then we're going to multiply a bunch of things together to get our final input into our torque math. So we can multiply the make vector times the clamped value from back here. So multiply that directly. Also multiply the flip axis, this variable here that we set. So go ahead and get that from down here. And then this final number here is going to be the power. So you can make a new variable for this, for how much power you want into your soft aim. I might do that too. I might just go ahead and do that now actually. Promotes a variable, and let's call it soft aim amount, I guess that's fine. Bit of a long name, but all right, it's defaulted to 10 for the default value. That's good. And then just put this into your input for the torque math. The torque math is already being solved for your desired rotation anyway, so it already knows which thruster to fire based on what you're trying to do here for the input, and everything should work pretty beautifully. So let's just go ahead and connect this soft aim here and leave the torque stabilizers on for now. We'll do something else with that later. And also turn off the normal torque thrust that I'm applying so that it's not giving me double values. And we'll have this on in different scenarios, this normal torque thrust. But look, it's aligning with the camera. I can look in all different directions. It'll overshoot a bit and then come back. So I can mess around with that too by subtracting the like the inverse of the radial torque. Now what you should have is a soft look system for thrust. No matter what kind of thrust system you have, honestly, that soft look should work for it. If you're using directly applying torque, you can use it for that too, and it'll work just fine. If you just want to do like add torque to the capsule instead of using thrusters. But what's on the menu next? As you can see, I got some 3 conspicuous shapes here, and what we need to do now is walk on this here planet. Excuse all the crazy wobble. I haven't coded anything for that. Just trying to get this vertical slice done real quick in a couple sittings. So we can jump into that. We can jump into planet normal matching. I already have gravity. It's gravitizing me to the planet's center, and I can gravitize to separate planets over here one at a time. So that's nice. It's giving me some Super Mario Sunshine feels, and I do want to have some pretty close planets and cool things going on. So it's gonna be cool. Let's make it so that this planet acts as if it's a world itself, and allow ourselves to walk upon it, Neil Armstrong style. First, let's take a look at the math that I have so far. And basically, it's just getting the display name of the planet after I begin overlap to it. So event begin overlap, get the component, cast to BP planet if it can, if I'm overlapping with the BP planet. And once it does, if it's true, just go ahead and set this as a BP planet variable. And there's a bunch of different things in that variable that I can now get. So at the end of my event tick, pretty expensive stuff. So I did a is valid get. Get the if you want to do that, get the BP planet and then right click on it, convert to validated get is how you get this node. And if it is valid, it starts doing all the rest of this logic here. So it doesn't do it all the time. And I can do some pretty cool stuff with that, turning it on and off and setting the gravity when it's safe to and all that jazz. So if it is valid, we're going to go ahead and get some different things out of the planet, get the gravity collision, and get the gravity direction. So the reason to do that is this logic down here, this get overlapping component. This just tells me that I'm touching a planet. It doesn't tell me what to do with it at all. So if I'm touching a planet, if I'm touching a, galaxies folder, BP planet, and inside the BP planet, it's got some stuff. So if I'm touching the planet, it will go ahead and get that planet. And inside the planet, I've got a gravity collision sphere here. As you can see, it's called the same thing, gravity collision. So I'm just getting this component and setting that as a gravity collision component, and also getting a gravity direction, which I'm calculating inside of here by getting the world location of the body of the planet and the world location of the capsule component of the character. So inside the BP planet, it's casting the character, getting the capsule component, setting it, and with that capsule component, getting the location and subtracting it from the body location. So location of the planet minus the location of yourself, your capsule component, or whatever you want to do. Normalize that value. Keep it at 0.0001. Normalize that value and set that as your gravity direction. That is now all you need. So with this value, you can fly towards the planet. Oh, I forgot to tell you. Gravity collision, that sphere here, I went ahead and got that. So get gravity collision and then get overlapping actors. And it loops through overlapping actors, meaning looping through the character class and making sure that if it's a character, it's going to do all this stuff. So I just put that into the array, and then the array element pull out from there. Make sure you pull out from there to get the character BP. You can actually just get character. You don't have to get the character BP. Let me see. BP. No. It's cast to character. This might clean it up a bit because third person has more stuff than the character class actually has, and there's no reason for me to have all that stuff. So cast a character, and it still works. So I'm gonna fly away from it real quick. I don't want to fly towards the planet right now. But all right. Wait, let me just make sure. Okay. Yeah. Here's where I'm adding the world rotation of the capsule component. So I'm getting the gravity direction and multiplying that by -1 to make a rotator out of the Z and X. Z is this value for the gravity direction, obviously. And then I'm also rotating the forward vector, which I don't know if I want to be doing that. I don't really know if I want to be doing that. I think rotating the Z is enough. We'll see. But I am getting a R interp 2. The current rotation is whatever the current rotation is right now for the capsule component. Get world rotation. And then the target is the target of the make rotation from ZX. World delta for the delta seconds, and then 10 seconds for the interpolation speed. So pretty slow interpolation. All right, now that we've cleaned it up a bit, I can show you the rest of the logic. Everything else to do with planet walking and matching the camera, whatnot. First and foremost, I added at the beginning of the tick a new function. And this one is a sphere trace, tracing the floor and just simply getting the world location of the capsule and then up vector of that, multiply it by -90, and then add those two things together to get our endpoint. Our beginning point is just the world location itself. That's it. And the out hit normal, we want to save that, set that as a variable. The out hit location is a variable. And then grounded, we made this variable by doing a out hit, blocking hit, and out hit distance. So out hit distance must be less than 100. And sorry peeps, I'm a little bit sick at the moment, but we're trying to struggle through it. We're trying to get through it, you know. We get through things like this. We just keep working. We don't stop. Let me delete some of this because this is doing absolutely nothing. So if is grounded is true, this branch is going to set active to false for all of the thrusters. Turn off all the thrusters. And this isn't really working the way that I expected in some cases, but it at least works sometimes. So it's a good start. Capsule component, we're going to set simulate physics to off. This is the part that kind of trips it up a little bit, I think. I tried having this before, it didn't work. After doesn't really work too well either. So at least it's turning it on and off. It's just that it gives me a bunch of errors. Now for the false. After false, if you're jumping, so if you press the jump button, then it can get into simulate physics, but only if you press jump. All right, now that we're out of that function, let's go ahead and name that one. Rename it floor, or maybe get floor. So our get floor function, and then our set gravity direction function. This is just from the character movement itself. I didn't have to make this one. It gets the gravity direction from our planet gravity direction that we're pulling from the planet BP. Setting that as our new gravity direction now makes everything work with the character movement component, so we don't have to fix anything with that, which is really nice. Torque stabilizer, still got that on, which I might not even need that on. Let me see if it turns itself off. Yes, it does. It turns itself off if the character is grounded, which is nice. I can, I'll leave this be. I won't change anything. Let me see if there's anything else fun here. So I'm setting the world rotation of the gravity anchor on the character, which is its own scene component. And then what's fun is I'm matching the gravity or the capsule component and the character boom to that gravity anchor's world rotation separately, so that if I want to split these out and make it so that one is working but the other one isn't or something, I can do that. And this would be in a use case of maybe doing like some flight over the planet with the ship, making sure that we can still have physics and stuff going. So maybe I want to turn off the capsule component rotation and keep the camera boom rotation going. So I'll show you how all that works. Look, I can, oh wait, let me show you first. You can run around, you know, just as normal. The camera is a bit wonky right now because I turned off the normal camera, but we can realign it. This is the flight camera that's on right now. Of course, I'll have the normal camera on whenever you're on planet, so that you don't have to worry about this orientation situation. But we'll worry about that later. It's a minor thing that I can manually fix, so I'm just not worried about it. But watch this. You can run around, and I got my sphere trace there. When you jump, now you're airborne, and it's using thrusters, using some physics thrusters. I can move around looking in all directions. No worries on any gimbal lock situations. It's using quaternions to do all the math. For the thrusters, has roll, and it does smoothly rotate. It's just very low power on the soft camera orientation right now, but it's using the thrusters in order to orient the character to the correct camera orientation, using these 6 here, top, bottom, and all around. And the normal movement thrusters are all in the middle, all at 0. So altogether 12 thrusters. Fun part is we can jump up and go over to this fake planet that we have set up here, and I'm smoothly matching the rotation. Boom. Now I'm walking on it, and the camera right now is just set to the character rotation. So that's kind of what we're stuck with at the moment, but we'll fix it. Let the mouse move the camera based on the character origin. All right, we made it to the end of the video. Thanks for checking it out. Thanks for hanging out just a little bit. Do you like these longer form videos? What do you prefer? 30 minutes, an hour, 10 minutes, 15? Let me know down in the comments. I'm going to have some more modeling videos out very soon, so you can get to see some of that. That's actually going to be the very next video. And then we're actually going to have a playtest coming out very soon as well. And I just want to say congratulations to the channel. It's 50 subscribers in. We got a 51 actually as of today. So thank you to everybody. And hopefully we can get up to 100. If we get up to 100, how about this? I'll go ahead and post a playable little demo. It's not going to have anything really but just the movement. But if I get 100 people subscribed, then I'll commit to putting out some updates and making sure that they're playable. So you can mess around with the systems, and you know, if you have a PC, download it real quick, and let me know what you think. So all right, once again, thanks for checking out the video. See you on the next one.